Hi everyone, welcome back to my YouTube channel. So I'm back with one more video, and recently I have received a request from one of the students in order to show clearly how to check the assertion failures in SV Testbench code. So yes, in today's video I'm going to explain that. And before getting into today's video, if you are new to this channel, consider subscribing this channel and hit on the notification bell also. And please share this video to all your friends who are also interested in entering into design and verification domain within VLSI. So, as we already know that assertions are very important in system Verilog. Similarly, you need to know how to check the assertion failure because we basically write assertions in order to reduce the checking time of failures. So, which is why assertion failures, even though you know how to write assertion, it is very important to know how to check the assertion failures in a particular SV test bench code, right? So yes, let's not waste any more time and let's get into today's video. I'm going to take one example and explain it clearly to you so that it will be easily understood by you. And after listening to this video, if you are having any doubts, you can ping me in the comment box. I'll definitely answer your questions, right? So let's get into today's video. So if you see the assertion program here, okay, module assertion, here I am taking clock as inputs and two inputs which are request 1 and request 2, req1 req2. So always I have generated the clock, always at the rate hash 2 is the clock cycle, total time period of clock is 4 time units. Okay, clock will be negate of clock for every 2 clock cycles, for every 2 units of time, right? And then I am writing sequence, so I am having only one sequence here. As I told you, you can have one sequence or more number of sequences also. So what is the sequence here? Request 1 star 2 hash hash 2 request 2. That means after request 1 is high, then after 2 clock cycles request 2 should be high. So this is my condition. Now I want to assert this condition. What I want to do here, I am just initiating the property. So within property I am writing that at the rate of passage of clock, for every passage of clock this condition needs to be checked. What is the condition that needs to be checked? Request 1 star 2 request 2 needs to be checked. So I'm writing it in the property, and then I have ended the property, and then I am asserting the property. So this is the way how you will assert. Okay, so assert property of prop. So what is the prop? Prop is nothing but the name of the property. So I am asserting this property. Okay, and then in order to see the waveforms, you will be writing this dump file. Okay, in order to see the waveform on the EDA playground, you will be using this dump file thing. Presently, I am not able to open the waveform due to some net issues. So I'll be explaining that in the some other video by showing the waveform. But as for today, I'll be just showing you how the assertion fails on the log file itself. Okay, don't worry, it will be clear for you. Okay, so now I'm just giving the input values. I'm just doing the input values, like if you see here, first initially at 0 time delay I'm just giving the values as 0 and 0, and then based on the time delay, see, for 4 time units I have made request 1, and then since I didn't give any time delay here, again this also be request 2 also be 1 will for hash 4 only. Next hash 6 request 1 is 0, request 2 is 0, hash 10 request 1 is 0, hash 20 request 2 is. In this way I'm just throwing some values and then I'm finishing it, and then I'm ending the module. Now if you see here, this is my condition. So now I want to check where the assertion is being failed. Okay, so now if you run this particular property, you will be seen where the assertions are being failed. So from this you can check where the assertions are failed, and then you can check the that particular time point where the assertion is being failed, and you can do it. So let me run it and show you. Let us see where the assertions are being failed. So see, here if you see at 2 nanoseconds the assertion is failed. Okay, and then at 18, at 22 nanoseconds, at 26 nanoseconds. So these are the time slots where the assertions are being failed, and in the remaining places the assertions are passed. So let us do one thing here. Let us see this one. See what I have done here is, here after request 1, after 2 clock cycles, the request 2 should be followed. Okay, so this is the assertion that I have done. So for that case, what I have given here, after 4 I have given 6. So it is having 2 nanoseconds of time where both are high. Okay, so because since I have given this, I have the request is the assertion is failed after 18 nanoseconds. Now for example, if I remove this particular 6 time seconds and if I run this code, what is going to happen? Okay, so the condition like 4 after 4, here it is again the request to is 1 for again 4 nanoseconds only, but it's not 2 nanoseconds. That means there is no 2 time clock cycles of time delay. So which is why if you see here at 14 nanoseconds also the session is failed. Okay, for example, if you are not if you're keeping this as hash 6 and if you run this code, what will happen at 14 nanoseconds? You don't see that the assertion has been failed. Okay, so if you see here at 14 nanoseconds, it is not failed. Okay, at 18 nanoseconds, it is being the assertion is being failed. Okay, so in this way, depending upon the time second, the time units that you observe, you can just check at that particular time in the in the waveform so that you will get the place where the assertion or the logic has actually failed. So this is how you will be using assertions in your system Verilog test bench development. So this is all for today. If you like this video, please do like it and also share it to all the VLS aspirants who also want to learn this Verilog system Verilog and UVM courses. That is all for today. Thank you all.